Good morning class. We have studied earlier about the matter class 9, the part 1. That was the characteristics of matter. Now we will be studying the different state of matter. What are the different states of matter? That are solid, liquid and gas. So mainly what we will study in the solid, liquid, gas, what we will study the arrangement, how the solids are arranged, how the liquids are arranged, how the gas are arranged. So how they are arranged? So if they are arranged like that, so how there will be the movement, what will be the kinetic energy, what will be the collision. So this depends upon the arrangement of the states of matter, that are solid, liquid, gas, how they are arranged. Before starting the solid, liquid and gas arrangement, we need to know that one thing, Brownian motion. Brownian motion. What happened ki particles, matter have some motion. Matter have some motion. And that zigzag motion of the matter is called what? Brownian motion. The matter exists. The matter has some motion inside them. The particles move in the matter. And how the particles move? In which type of motion? Zigzag motion. And that zigzag motion is called what? Brownian motion. And Brownian motion results in what? The kinetic energy. And kinetic energy is what? The movement of the particle. The movement of the particle. The movement of the particle, and as the movement of particle is occurring, what will happen? The collision. The collision of the matter and what? The vibration of the matter. Vibration of the matter. So what will we be studying? One by one we will study in the solid how they are packed. See, this is the arrangement of solid. This is the arrangement of solid. And how the solid are packed? Is there any spaces in between solid? No spaces, or the spaces are negligible. They are rigid. Rigid means what? They are very hard. This is what? Solid. They are not able to move. That means they are rigid. They are not compressible. Not compressible. But not compressible, but one exception is there. Sponge and rubber band. Sponge and rubber band. What happens in sponge and rubber band? Sponge and rubber band are type of porous solid. They are compressible. As we have studied about the properties of solid, solid are non-compressible. They can't be compressed. See, this is a solid. Is this be compressed? No. The duster can be compressed? No. This board can be compressed? No. But sponge ball, you have seen that smiley ball, sponge ball. So they are called what? Porous solid. So porous solid have tiny spaces. Porous solid have tiny spaces in between. Tiny spaces in between them. And as we compress the ball, what happened? That space come closer. They are compressed. And as we release, they are about their position. They are in their position, about their position. So, as they come in position, why they come in position and why they are compressed? Because they are having some tiny spaces in between them, and accordingly they come into their shape, and they are able to compress. And second exception is what? Rubber band. Ever you have seen the rubber band? What we do with rubber band? We can stretch, and rubber band, then when we leave that rubber band, and they come to its position. So they are compressible. The two exceptions to this not compressible property of solid are what? Rubber band and sponge. And sponge is called what? Sponge is called porous solid. So if there is less spaces in solid, what will happen? If there is less spaces in that, so what will happen? There will be less movement. The movement will what? Movement in solid will be ekdam negligible. There will be no. Like if you are sitting in a row, if you are sitting compactly, so what happens? You are able to move or not? No, you are not able to move properly. So the movement is very less. Kinetic energy will be also less. So if the kinetic energy will be less, there will be very less collision. Less collision. So understood what is the property of solid? They are closely packed. They have no spaces in between them. They have the negligible space. They are rigid in structure. They are not compressible. But they are not compressible, but mark it important. One exception, two exceptions are there. That exception are called what? Sponge and rubber band. Sponge is called what? Porous solid. Porous solid have spaces in them. And that as we put some force, they are easily compressible. And that's why they are called porous solid. And rubber band is also the exception. As we compress the rubber band, they are elastin. They change their shape. So these are the two exceptions of this property of solid, that they are not compressible. Coming to liquid. What happened with liquid? In liquid, there are some spaces. Like liquids are arranged like this. So they have some spaces. So we can say liquid have what? Liquid has spaces. They have spaces. So they are easy to move. Yes, they are easy to move. They don't have fixed shape and volume. They don't have fixed shape. What if you keep 1 liter of water in a long bottle? So that will take a shape of that long bottle. If you keep the 1 liter of water in a broad bottle, they will take the shape of what? The broad bottle. So they don't have the fixed shape. Volume may be fixed, but shape is not fixed. Coming to the kinetic energy, vibration. If there have some spaces, the vibration will be more. The collision will be more. So kinetic energy will be more. One more thing, liquid has the property to flow. Liquid has what? Liquid has the property to flow. And this property of flowing is called what? Fluidity. The property of liquid which can flow is called fluidity. Yes, this is called fluidity. Now, after that, what is that? Kinetic energy in the liquid is what? Kinetic energy more than solid. And they are they are also as much as gas, but they are little bit compressible. Like for example, if you fill water with the balloon, water in a balloon, so what will happen? You are able to compress the balloon. Yes, you will be able to compress that balloon. So they have some very less property of compressing, but very less than gases. Coming to gases, how the gases are arranged? how the gases are arranged. How the gases are arranged. See, the arrangement of gases will be like this. So, see, what can you observe from this? From this you can observe that gases have space in between them. Yes, they have very large They have very large spaces. They have very large intramolecular spaces in between them. So if they have large intermolecular spaces in them, so how will be the movement? The movement will be how? The movement will be very random. Movement will be very random. And the collision will be more. See, one molecule coming from this side, one molecule coming from that side, one molecule coming from that side. They are not in a queue. So what will happen? There are many chances to collide with each other. So they have the chances to collide with each other. So the collision is more, so kinetic energy will be more. So kinetic energy in gas is the most than to liquid and very least in solid. Now one more property which is very important in solid that you also use in everyday life. What is that property? Compressibility. Compressibility. Gas has the very most property to compress. Have you ever seen gases LPG used in your home? CNG. What is CNG? Yes, compressed natural gas. What is LPG? Liquefied petroleum gas. And how? How they are being used? They are being, you have used LPG. How? You use the gas in a day and they finished. No. Actually what happened, there are with very much gas in your gas cylinder, and that this is actually not like anyway, cylinder is fulfilled with what? LPG, liquefied petroleum gas, and they are there in the what form? Compressed form. In the compressed form, liquid natural gas takes place. They are in the compressed form, and that is the reason after many uses we use LPG for cooking. They are used to cook food for many days, rather than it is not consumed in a day, like that cylinder is filled with much amount of LPG that can be used for many days. Compressed natural gas. Gas is in the form of compressed natural gas. Compressed natural gas is used where? Automobile. Nowadays, car, auto. So these compressed natural gas is a form of natural gas which is used in what? Compressed form. So you have understood what is the compressibility property of gas? Yes, compressibility of gas is very much important. So gas is coming to the compressibility, coming to the intermolecular space. Intermolecular space. So intermolecular space in gases is more. Liquid in less and solid very temperature. Coming to diffusion also. Sorry, after that diffusion we will discuss. Rigidity. Solid is much more rigid liquid than gas. So you have understood the order, increasing order or decreasing order of kinetic energy, intermolecular space and rigidity of solid. These were the properties of states of matter or arrangement of state of matter. Like state of matter is what? Solid, liquid and gas. Now we will be studying interconversion of matter. Now we will be studying interconversion What is interconversion of matter? Interconversion of matter is what? When matter is converted from one state to another state, that is called interconversion of matter. See, one state to another. Solid is one state, liquid is another state, and gas is what? Another state. Matter means state of matter. Like solid is converted to liquid, liquid to gas, and gas to liquid, liquid to solid. That is called what? Interconversion of matter. You have seen ice? Yes. So ice is what? Ice is in form of solid. When ice is melted, it is converted into liquid. When it is boiled, it converted into gas. So when ice solid is converted into liquid, what is the process? When solid is converted into liquid, that process is called melting. Liquid to gas, melting, or when liquid is converted to gas, when gas is converted to liquid, that is called what? Condensation. And when liquid is converted to solid, what is called? Solidification. When liquid is converted to solid, this process is called solidification. You have seen water is converted to ice. That is called what? Solid. Yes. Then in next class we will discuss it in more broad form.